Good afternoon, everybody. I welcome you all to my channel on basic chemistry. Today's topic is on hybridization, the part 1 which I have already taught you, and now today I am teaching on hybridization part 2, where I shall tell you sp, sp2 and sp3 hybridization. As you know, it is spherically symmetrical. It is spherically symmetrical. P, you know, it is a dumbbell. Now, in the definition of hybridization, we know the number of orbitals that is mixed will give rise to the same number of hybrid orbitals. Now, when 1s will mix with 1p, the 1 plus 1 the product is 2 sp. We can write it in a different way. 1 s plus 1 p, the product is 2 sp. This is sp. These two sp hybrid, these are orbitals. 1s and 1p, they are orbitals. And 2 sp, the sp is hybrid orbitals. Now these two sp hybrid orbitals, they will repel each other and try to remain at a far distance. That is possible only when this structure will be there. Like the 2sp, one is like this, the other one is like this. This is 1sp, this is 1sp. The 2sp hybrid orbitals, they will repel each other, and the structure is like this, making an angle of 180 degree. And the shape is, it's a straight line. We call the shape as linear. So for all sp hybridization, the bond angle is 180 degree and the shape is linear. Now I shall tell you sp2. When 1s will combine with 2p, the product is 1 plus 2 is 3. The product is sp2. Or 1s will combine with 2p. The product is 3 sp2. These three sp2 hybrid orbitals, they will try to remain far away from each other because of repulsion, and that is possible in case of a triangular shape or a trigonal shape. I am showing how the shape is. This is the orbital shape. It is called triangular shape or a trigonal shape. The bond angle is 120 degree. So for hybridization, sp2 bond angle is 120 degree. Shape is triangular planar or trigonal planar. I have just taught you about hybridization. SP where the bond angle is 180 degree and the shape is linear. Now the last part SP3 I shall tell you. When 1s will combine with 3p, the product is 1 plus 3 is 4, sp3. This is like this, 1s plus 3p, the product is 4 sp3. These 4 sp3 hybrid orbitals, they will repel each other, and how the shape is, I'm drawing it in the drawing its figure. This is 1 sp3, this is 1 sp3, this is 1 sp3, and this one is inside, it is 1 sp3. The line structure is like this. This is 1, here is 1, here is 1, and here is 1. The bond angle is 109.5 degree. So for hybridization sp3, bond angle 109.5 degree or 109.28 degree. Shape is tetrahedral or regular tetrahedron. This is the line structure. This is the orbital structure of sp3. Now I want to tell you the individual examples of sp For sp, I shall tell you the shape of C2H2. It is ethyl or acetylene. For sp2, I shall tell you for C2H4, which is ethene or ethylene. For sp3, the example is CH4 ethane. This is all about sp, sp2 and sp3 hybridization. I was thinking of telling you the detailed structure of sp, sp2, sp3 and more and many other examples, but I do not know how far you are liking my teaching. If you really like my teaching, then I shall proceed ahead with many other examples. For the time being today, goodbye, good night, and see you in the next class. Thank you. Thank you.